So welcome students. In this video, we are going to try to understand the concept of set theory. Set theory is a very important concept in mathematics. So this is a concept where we try to analyze collection of objects. As we know, a set is a collection of objects. That is the general English understanding of a set. So we talk about collection of objects. For example, your class is a collection of students. You have the collection of rivers in India. So in similar way, you have a colony is a collection of houses. Okay, you can think about a library is a collection of books. So the concept of collection is a very intuitive concept to human beings. But this set theory tries to get this concept of collection into a standard framework of mathematical theory. So now let us try to understand the difference between a general collection and a mathematical set. So what is the definition of a mathematical set? So a mathematical set is a collection of well-defined and well-distinguishable objects. So a set is defined as collection of well-defined and well-distinguishable objects. So there are two important words, which is well-defined and well-distinguishable objects. So what is the meaning of well-defined? A set should be a collection of well-defined objects. For example, what this means is the definition of the set should be very clear. That means once we define a set, we should be able to decide whether a particular object belongs to the set or does not belong to the set without any ambiguity. For example, I talk about collection of natural numbers. So collection of natural numbers. So is it a mathematical set? The answer is yes. Because so once we know what this natural number set is, so if you take any number and I tell you any number, if you know the concept of natural numbers, obviously you should know the concept of natural numbers, you will be able to decide whether that number belongs to the set or does not belong to the set. So let us say that n is the set of natural numbers. So if you take the number 1, we can say that 1 belongs to the set of natural number. So this is a new symbol, which is the symbol for belongs to. For example, 1.5 is also a number. So can you decide whether this belongs to the set of natural numbers or not? So we say that we can decide that 1.5 does not belong to natural numbers. So there is no ambiguity here. So now you may say, sir, any collection doesn't have ambiguity, right? What is the example of a set which has some ambiguity? For example, collection of clever people, clever students in a class. So this is also a collection, but this collection is not well defined because this cleverness is an adjective and this cleverness is subjective. For example, if I take a student, some students may think that he is clever and some students may think that he is not clever. So whether a boy is clever or not is a subjective opinion rather than a mathematical truth. So the collection of clever students in a class is not a mathematical set. You can think of it as a collection, but this is not well defined. And the second is, I think you have understood what well defined is. Second attribute of sets, objects of a set, is that the objects have to be well distinguishable. That means if you take any two objects in the set, they should be distinguishable from each other. For example, 1 belongs to natural numbers and 2 belongs to natural numbers. 1 is not same as 2. So the objects have to be well distinguishable and the objects have to be well defined. So once these two criterions are met, that collection is called a set. Now, the objects which belong to the set, we say that those are the elements of the set. So next we have something called elements of the set. So once we define a set, we can decide whether an element belongs to the set or does not belong to the set. So you have very nice symbol for belongs to. So this is the Greek symbol for epsilon. This is a symbol for belongs to. And this is a symbol for does not belong to. So if an object satisfies the definition of the set, we say that that object belongs to the set. If the object does not satisfy, we say that the object does not belong to the set. So next we have to understand how to represent a set. So how do we write a set mathematically? Okay, so the ways in which we write a set are broadly classified into two types. So one is roster form. The other is set builder form. So sets are represented either in roster form or set builder form. So first we'll understand what is roster form. Next we'll understand what is set builder form. Before actually going to roster form, usually sets are denoted by capital letters. That's a usual convention that we use. The set is denoted by a capital letter and the elements of the set are denoted by small letters. The elements of the set are denoted by small letters. A set itself is denoted by capital letter and the elements of the set are denoted by small letters. That's a usual convention. So it's usual convention. There is no hard and fast rule that you have to do this. So even if you denote a set by small letter, it's okay for me. This is a usual thing. Okay. So now in roster form, what we do is we represent the set A. So we use curly brackets, and within curly brackets we write all the elements that belong to the set. For example, I'm talking about, let us say that A is a set of vowels in English language. Vowels in English alphabet. So if I have to write this set in roster form, the roster form of this set would be A is within curly brackets the elements A, E, I, O, U. So there are 5 elements in this set and we write all the 5 elements separated by commas. So this type of representation is called roster form. So if the sets are very basic, so it's comfortable to just write the set in roster form. For example, I'm talking about natural numbers. So you can write this as, there are some sets which are called finite sets, there are some sets which are called infinite sets. If the number of elements in a set is finite, then such a set is called finite set. If the number of elements in a set is infinite, it is called a infinite set. So the set of natural numbers, as we know, is infinite. So if you want to represent infinite sets in roster form, we'll do it like this. Set natural numbers is a set 1, 2, 3, 4. So we use 3 dots. So on. So when you use 3 dots, that means it's an infinite set, and you have to follow the same pattern as you have for the elements before it. So natural numbers can be represented in roster form as set 1, 2, 3, 4, so on. So if you write all the elements of a set inside curly brackets or flower brackets where individual elements are separated by commas, such type of representation is called roster form. Next, you have set builder form. So in set builder form, what you do is you specify the property of the elements that are belonging to the set. You have to write that property which each and every element in this set satisfies, and no other element outside the set satisfies. You have to write a property which very clearly defines the elements of this set. For example, I want to write, assume that you have the set 1, 2, 3, 4, 5. Assume that this is the roster form of the set. I want to write this in set builder form. Now the question that you need to ask is, so what is the special property that each and every element of this set satisfies, and no other element which is not there in this set doesn't satisfy? Okay, so I can clearly see that all these are natural numbers. I can clearly see that all these are natural numbers, but these natural numbers are not more than 5. So this general way in which we write set builder form is we denote the element of the set as x, such that we write the property that x satisfies. So this set is a set containing elements of the form x, where x belongs to natural numbers, x is a natural number, and x is less than or equal to 5. So we write the general element of the set before such that this double dots denote such that that means what is the condition that this x has to satisfy. So x such that x is a natural number and x is less than or equal to 5. So based on this definition, you can create this set. So what is the property that this x satisfies? X is a natural number and less than or equal to 5. So what are the natural numbers less than or equal to 5? 1, 2, 3, 4, 5. So you can build the set using set builder form. Okay, so this sometimes this such that can also be denoted by a hyphen. So x such that x belongs to natural numbers and x less than or equal to 5. So set builder form is also a very convenient way to represent sets. So the general form is curly bracket, the element that is present in the set, and what is the condition that that element has to satisfy. Okay, so now let us look at some very basic examples of set builder form and roster form. So in roster form, one thing that you need to remember is the order of the elements doesn't matter. For example, A is the set AEIOU. The set AIOEU. So these two sets are same because this set also contains the same 5 elements. This set also contains the same 5 elements. So when you write elements of the elements of the set in roster form, the order of the elements doesn't matter. So whatever order you write, as long as the elements are same, the sets are same. And also the second thing is, when you write elements in roster form, you don't write the element more than once. So you write the element only once, one element only once. For example, you don't write AEIOU. Okay, so because as we have said, the elements of the set has to be well distinguishable. If you write the set as AEIOU, so what is the distinguishability between these two elements? So these two elements are not distinguishable. So a set should not contain two elements which are not indistinguishable. Okay, so the elements have to be distinguishable. So in the roster form, we write the elements only once. So there are two things in roster form that you need to remember. So one is order is not important, and second is no repetition is allowed. Okay, so now let us look at some very simple examples of sets written in roster form and the corresponding set builder form. Okay, so for example, let us take examples. So for example, you have a set 1 by 2, 1 by 3, 1 by 4, 1 by 5, so on. So let us take this infinite set. So this is a roster form. So how do you write it in set builder form? So this can be written as a set containing, you have to observe the pattern. So can you see that the pattern is 1 by something? So all the elements are of the form 1 by x, such that all the elements are of the form 1 by x, such that x belongs to natural numbers, right? The denominators are natural numbers, but there is no 1. 1 by 1 is not there. X belongs to natural numbers and x is greater than 1. All the elements of the form 1 by x, where x is a natural number, the denominator is a natural number, and a number which is greater than 1. So this is the corresponding set builder form of this set. So clearly, as you can see, this is the format of the element in the set, and this is the property which the variable in the general element of the set satisfies. For example, let us look at 2 by 3, 3 by 4, 4 by 5, 5 by 6. Let us say that there are 4 elements in this. So what is the set builder form that you can write? So clearly the elements are of the form something by the next number, a number by the next number. So you can think of this as n by n plus 1. All the elements in this set are of the form n by n plus 1, such that n belongs to natural numbers. Obviously n is a natural number. And can you say that n is in between 2 and 5? This n is between 2 and 5. That means if n is 2, you get 2 by 3. If n is 3, you get 3 by 4. If n is 4, you get 4 by 5. If n is 5, you get 5 by 6. So this can be a valid set builder form. Sir, should we write the set builder form only like this, or can I create some other way of expressing? So the answer is, the set builder form of a particular roster form is not unique. You can have more than one different ways in which you can write the set builder form. Okay, so I think you have understood how to convert a particular roster form set into set builder form. Now let us try to understand a tricky example of reconverting. For example, let us say that you have a set of x such that x is a letter of the word lion. So x such that x is a letter of the word loyal. So assume that this is a set builder form. So the set is containing an element x such that x is a letter of the word loyal. So now what is the set roster form of this? Obviously L belongs to loyal, O, Y, A. So you don't need to write the next L, because when you write an element in roster form, you have to write it only once. So this L and this L are not distinguishable, are indistinguishable. So there are only 4 letters that belong to the word loyal. It's not, loyal might be a 5-letter word, but it is made up of only 4 English letters. So x such that x is a letter of the word loyal is same as a set containing L, O, Y, A. Clear? And you can write the order of these elements in any way you want. Y, O, A, L. This is also same. Okay. So I think you have understood what the set builder form and roster form is. So this concept is quite simple. So we don't need to spend too much time on this. So we'll have a very small exercise that will be attached with this video. It will be there in the description. So if you want, you can just go and solve that assignment. That would clear all your doubts.